Myself Neha Mittal. I am working as a assistant professor at Ramesh Institute of Vocational and Technical Education, Greater Noida. In this lecture, I am going to discuss Unit 3rd under the subject Medicinal Chemistry. Code BP 601. This is a Unit 2 in which we will discuss macrolides. So, in this class, in this video lecture, we are going to discuss about the macrolide antibiotic, which is a part of medicinal chemistry Unit 2. In this, what are the main contents we are going to discuss? We will discuss what are the macrolides, or we can say a general introduction to macrolides, chemistry of macrolides, mechanism of action, SAR, and then we will study the 3 compounds of macrolide, means erythromycin, clarithromycin and azithromycin. First of all, before starting the macrolide, I would like to give a brief on what do we understand by the antibiotics. Antibiotics क्या होते हैं? हम देखते हैं antibiotics are the chemical substances which are obtained from the various species of microorganisms. What can be the microorganisms? They can be bacteria, fungus, etc. So, antibiotics are the chemical substances which are produced from the microorganism like bacteria and fungus, and which are helpful in destroying the other microorganism. So, in collectively we can say that antibiotics are the chemical substance obtained from the microorganism and are used to suppress the growth of other microorganisms, and in higher concentration they can eventually die them. Next, we will study about the macrolides. Macrolides were originally given to the antibiotic which was produced by the species of Streptomyces. It was obtained from the Streptomyces. अगर हम मैक्रोलाइड्स के बारे में बात करें तो जैसे मैक्रोलाइड्स के अगर टर्म्स को हम बीच में से स्प्लिट कर दें, सो हम यहाँ से समझ पाएंगे दैट इट इज़ मेड अप ऑफ 2 पार्ट्स, मैक्रो एंड लाइट्स. मैक्रो मीन्स लार्ज, बिग, एंड लाइट्स मीन्स लेक्टोन रिंग. यानी कि मैक्रोलाइड्स आर अ ग्रुप ऑफ कंपाउंड विच हैव अ मैक्रोसाइक्लिक लेक्टोन रिंग which have 14 to 16 atom in their structure. So, here we can understand that macrolides are those compounds which contain lactone ring, macrocyclic lactone ring having 14 to 16 atom in their structure. If we talk about the classification, we see that depending upon the number of atoms present in the cyclic lactone ring, they are classified into 4 categories: 12 membered, 14 membered, 15 membered and 16 membered. If we see the example, we see that methamycin is an example of macrolide in which 12 membered 12 atoms are present in the lactone ring. Next we see 14 membered. 14 membered macrolides are classified into 2 parts. One is natural and second is semi-synthetic. What do we understand? Natural, which are obtained directly from the different species of microorganisms. Here we see the example of erythromycin. Same in the way, there is a category of semi-synthetic category of macrolides in which there is an example of clarithromycin. So, here we see that methamycin has 12 atom. Erythromycin and clarithromycin comes under the 14 membered compounds, and azithromycin is a macrolide in which 15 atoms are present. In the same way, speramycin contain 16 atoms in their structure. So, we will discuss one by one. First of all, we will understand what is the chemistry of macrolides. हमने जैसे अगर हम इस स्ट्रक्चर को ध्यान से देखें तो हम ये समझ पा रहे हैं कि इसके अंदर एक दिस इज अ इलेक्ट्रॉन रिंग which is in a complete cycle form, So, अगर हम मैक्रोलाइड को देखें, so मैक्रोलाइड के बेसिकली हम 3 पार्ट्स देखेंगे. The 3 important parts. First of all is इलेक्ट्रॉन रिंग. इलेक्ट्रॉन रिंग क्या होती है? इलेक्ट्रॉन रिंग इज अ साइक्लिक carboxylic esters containing usually 12 to 16 carbon atoms as we discussed in the previous slide. So, this is the first important part of macrolide in which we see a major cycle of electron ring containing 12 to 16 carbon atoms. Second, we see ketone group at 9th position. Ketone group at 9th position. इसके बाद थर्ड हम देखते हैं there is a amino sugar linked glycosidically to the nucleus. अगर हम मैक्रोलॉइड के स्ट्रक्चर को ध्यान से देखते हैं तो हम देखेंगे कि यहाँ पर 2 शुगर प्रेजेंट है. वन इज डेसोसामीन एंड सेकेंड इज क्लेडिनोज. So, in macrolide there are presence of 2 sugars, one is amino sugar, second is neutral sugar. They are linked through the glycosidic bond. So, an amino sugar linked glycosidically and the another one a neutral sugar linked to the electron ring through glycosidic bond. Next, we see that the presence of dimethyl amino. Here we can see that there is a presence of dimethyl amino moiety presence. This is something which makes it basic in nature and helpful in formation of the salt which are used in many diseases for their treatment. So, once more I would like to conclude this. The chemistry of macrolide, we see the macrocyclic ring. This is the macrocyclic ring in which 2 sugar moieties are present. One is a neutral, second is amino sugar. Both sugars are linked through the electron ring by glycosidic bond. This is glycosidic bond. Presence of ketone group at 9th position and the presence of dimethyl at amino group is responsible for their basic character. So, this is all about the chemistry of macrolide. Further, we will see that how they work, how they kill the microorganisms, how they show their action. So, in this we will understand that they binds to the 23S ribosomal RNA of the 50S subunit. As we see that in bacteria they are the 2 part of the ribosomes, 50S and 30S. So, in ribosome of bacteria we see that they are the 2 parts, 50S and the 30S. Again there is a part of 23S in 50S. So, here we see that the macrolides binds to the 23S ribosomal part of the 50S subunit, and it interferes with the elongation of peptide chain which is responsible for the growth of microorganism. माइक्रोऑर्गेनिज्म के अंदर जब पेप्टाइड चेन का इलोंगेशन रुक जाता है, पेप्टाइड चेन की फर्दर ग्रोथ रुक जाती है, सो there is no further synthesis of protein, there is no further translation occurs. Hence protein synthesis disturbs and there is no protein synthesis takes place. At the last, bacteriostatic activity occurs, means the bacteria are now not more capable of producing their number. Bacteriostatic means जो बैक्टीरिया है उसकी संख्या धीरे धीरे कम हो रही है, बिकॉज दे आर नॉट एबल टू प्रोड्यूस मोर नंबर ड्यू टू द इनहिबिशन ऑफ प्रोटीन सिंथेसिस. अब प्रोटीन सिंथेसिस को कराने के लिए वी नीड द पेप्टाइड चेन इलोंगेशन, जो कि इस मैक्रोलॉइड ने आके डिस्टर्ब कर दिया है. सो अगर हम समझे दैट व्हाट इज द मैकेनिज्म ऑफ मैक्रोलॉइड, वी विल सी दैट macrolide interfere the elongation of peptide chain which is responsible for the protein synthesis and the survival and the growth of microorganisms. Hence the bacteriostatic activity occurs. In the next slide we will understand about the structure activity relationship of macrolide. What do we understand by the structure activity relationship? When we have a molecule, we will see कि हम किस पार्ट पे क्या मॉडिफिकेशन करके एक्टिविटी को बढ़ा सकते हैं, एक्टिविटी को डिक्रीज कर सकते हैं, या फिर हम अपने कंपाउंड्स के और अदर डेरिवेटिव्स क्या बना सकते हैं. सो दिस आर द स्ट्रक्चर एक्टिविटी रिलेशनशिप. अगर हमने मैक्रोलॉइड की स्ट्रक्चर जैसे मैंने प्रीवियस स्लाइड में भी डिस्कस करी, हमने ये जाना कि इसके अंदर इलेक्ट्रॉन रिंग का होना, दिस ketone group, the presence of ketone group, and presence of amino sugar, and presence of amino sugar are the basic characters which are required for their antibacterial activity. इसके बाद हमने देखा दोनों sugar, whether it is a amino sugar or whether it is a neutral sugar, they should be bonded glycosidically for their activity. This is a basic necessity of a macrolide, that both sugar, whether it is amino sugar or it is neutral sugar, they should be bonded through the glycosidic bond. Next, dimethyl amino group is important for the basic character. If we see the structure of this sugar, this is a clarinose sugar. So इसमें ऑलरेडी इसके अंदर अगर थोड़े बहुत हमने चेंजेस करके देखे, so we found that clarinose sugar was more potent than the ketolides. अगर हमने इस शुगर को चेंज करके कीटोलाइड से रिप्लेस किया, then we found that this compound was not much potent as comparison to clarinose. Next point which we it's very important also, हमने देखा कि बहुत सारे जो मैक्रोलॉइड्स थे they were unstable in acidic environment. जैसे ही मैक्रोलॉइड्स को एक एसिडिक एनवायरनमेंट के अंदर रखा जाता था, they started getting unstable. So to improve the acidic stability, what was done, this hydroxy group present at carbon number 6, this OH group present as carbon number 6 was replaced by methoxy group, as it is known as clarithromycin. So, if the hydroxyl group present at carbon number 6 was replaced by the methyl group, and it was now earlier it was hydroxy, now it is methoxy. So, we found that the new compound named clarithromycin was more acid stable. Now, we will start the erythromycin. We know that as we discussed earlier that there were the 12 membered, 14 membered, 15 membered and the 16 membered macrolides. But the commonly used macrolides are the erythromycin, clarithromycin and azithromycin, and we will discuss one by one. First of all, we will discuss erythromycin. इरेथ्रोमाइसिन में अगर हम देखते हैं सो इस वाली पोजीशन पे we'll find a ketone substitution, and on this here we find the OH. So, erythromycin is a natural occurring macrolide which was discovered in 1952. If we see the molecular formula, its molecular formula is C37H69NO13 and molecular weight is 733.93 gram per mole. As we discussed earlier that in the acidic environment erythromycin is not stable. Now, we will discuss about the properties of erythromycin. Erythromycin is very bitter in taste. Erythromycin was very bitter in taste. If we talk about the color, it is white in color, whitish or yellowish white in color. It is soluble in alcohol and very less soluble in water. If we talk about the introduction of erythromycin in GIT tract in gastric acid, we found that when erythromycin is orally administered, it gets deactivated by gastric acid because as I earlier said that it is unstable in acidic environment. It is unstable in acidic environment. So, to overcome this problem, the oral tablet must either contain a ester or some stable salt, or we can say that we can make a prodrug of erythromycin which is more stable in acidic environment. So, here we see the example of erythromycin palmitate. Erythromycin palmitate is a prodrug and it gets converted into the active erythromycin by the action of many enzymes or chemicals. We see that erythromycin has high solubility and it has masked the bitter taste of erythromycin. If we talk about the mode of action, so we see that the mode of action will be the same as it is a bacteriostatic in action. It is based on protein synthesis inhibition. It binds to the ribosomal unit, that is 23rd S part of the 50S part of ribosomal. Here there is an important thing that in humans we have the 40S and 60S subunit and we do not have the 50S subunit, means this is the only reason that erythromycin do not interfere with human peptide elongation chain, or we can say that erythromycin do not disturb the protein synthesis in human because it is active on 50S subunit and which is present in bacteria. If we talk about the humans, in humans ribosomes there are the two units 40S and 60S. And if we talk about the bacteria, then they have the unit 50S and 30S. Next, we will discuss about the uses of erythromycin. Erythromycin की ज़रूरत कहाँ कहाँ पड़ती है? Erythromycin is active against a number of bacterial infection like skin infection, respiratory infection, pelvic inflammation disease and syphilis. Next, we see that erythromycin is used to treat chlamydial infection. Erythromycin is used to treat chlamydial infection that can cause conjunctivitis of the newborn. जो newborn babies होते हैं उनके अंदर conjunctivitis cause हो सकता है, pneumonia of infants and urogenital infections in pregnancy. Next, we will see that the penicillin, there are the few compounds which are resistant. This drug is effective against many of the same organisms as penicillin, where penicillin resistance takes place. Means there are many drugs, there are many disease where penicillin G shows resistance. penicillin G काम नहीं करती, वहाँ पे भी erythromycin को यूज़ किया जा सकता है. Next, we will see that erythromycin is used to treat by many infections which are caused by gram positive bacteria, but not effective against all gram negative bacteria. Erythromycin is not active against penicillin resistant Streptococcus pneumonia strain. Next, we will discuss about the clarithromycin. As मैंने आपको पहले भी स्लाइड में समझाया था कि ये वाला जो OH है, OH in erythromycin, it is replaced by the OCH3, means there is a addition of methyl group. There is a addition of methyl group in erythromycin. So, clarithromycin is a semi-synthetic drug which is derived from the erythromycin by the addition of this methyl group. It is having a better absorption, less gastric irritation, half time is greater than clarithromycin, or overall we can say that it is having comparatively better effects than the erythromycin. The molecular formula, if we discuss about the molecular formula, it is C38H69NO13 and the molecular weight is 747.95. Uses, if we see the uses of clarithromycin, it is used in skin infection, sinus में अगर inflammation हो जाता है, sinusitis, upper and lower respiratory tract infection, whooping cough. Whooping cough में जो cough होती है उसकी intensity इतनी ज़्यादा होती है that sometimes we feel difficult in breathing also, and it is also used in atypical mycobacteria. इसके बाद हमारा last compound है that is azithromycin. एजिथ्रोमाइसिन में अगर हम ध्यान से देखते हैं तो इसके अंदर जैसे मैंने आपको बताया था क्लेरिथ्रोमाइसिन एंड एजिथ्रोमाइसिन आर द 14 मेंबर्ड compound, but it is a 16 membered compound. If we see then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and this 15. So, azithromycin is a 15 membered compound which is having a extra methyl group at nitro position. So, as we discussed, erythromycin and clarithromycin are the 14 atom containing compounds and azithromycin is a 15, this is a 15. So, it is a 15 membered ring. Here we can see also it is a 15 membered ring with nitrogen. These structure modification expand the acid stability and tissue penetration and better availability of the drugs, and hence we can say that azithromycin has the better bioavailability. If we talk about the drug interaction, we will see that azithromycin के अंदर हमने देखा they are the 15 membered lactone ring, whereas in erythromycin and clarithromycin there is a 14 membered compound. So, it does not activate the cytochrome P40 and thus it has less interaction than the erythromycin and clarithromycin. There are the antacids. Antacids do not alter the bioavailability of azithromycin but retard their absorption. So, it is suggested कि अगर आप एंटासिड्स खा रहे हैं तो या उन्हें खाने से 1 घंटा पहले लीजिए या फिर खाने के 2 घंटे बाद आप मेडिसिन को लीजिए ताकि आपका जो एब्जॉर्प्शन है उसमें कोई दिक्कत ना आए. If we are taking the azithromycin with nelfiravin, so we see that nelfiravin increases the plasma level of azithromycin, and in the last we will see that azithromycin can increase the therapeutic effect of anticoagulant. Then we will discuss about the uses. We will see that it is also used in many bacterial infections like respiratory, skin, community acquired ammonia, and also used to treat sexual transmitted disease. As we see that during the COVID, azithromycin was using to treat the sore throat of the patient. Contraindicated and warnings. It is contraindicated in patients जिसके साथ पहले से हाइपर सेंसिटिविटी की प्रॉब्लम है, जॉन्डिस या फिर लीवर के साथ जिस भी पेशेंट को लीवर का प्रॉब्लम है, वी सजेस्ट नॉट टू यूज एजिथ्रोमाइसिन इन दैट केस, as it also causes QT prongulation. So it is also suggested not to prescribe in those patients who has earlier history of heart related diseases. Thank you so much students. I hope आपने इस वाले लेक्चर से काफ़ी कुछ चीज़ें सीखी होंगी. Thank you so much.